Welcome back. In the previous segments, we have seen the types of installations and related structure type. If we see broadly, structures are of two types. Type A is the fixed type, type B is the non-fixed type. Non-fixed type structure is ballast type structure. Fixed type structure is of further two types. Type A, in which civil foundation is required. Type B, in which civil foundation is not required. In the case of tin shed type installation, the structure used is aluminium and it is fixed with the purlins. It does not require the civil foundations as the structure is mounted on the metallic roof of the tin shed. Civil foundation is required in the case when panels are to be mounted on the RCC rooftop. This particular section presents the civil foundations, the vertical columns of the structures and the mounting of the solar panels. Here you can see this rectangular block is presenting the civil foundations. So we are able to see two foundations in this particular section view. These are the vertical columns for the supporting of the purlins so that the panels can be mounted on the purlins. Here you can see that two panels are mounted with a tilt angle of 25 degree. You can also see here that the existing RCC slab has a tile mud fuska over it and the civil foundations are casted by putting up the mud fuska by chirping the slab so that a strong bond of the foundation can be made with the slab. The size of the civil foundation depends upon the structural analysis of the solar power plants. The wind pressure, the height of the solar panels are taken into consideration. With the civil work, there comes the calculation of the dead weight also. In this table, the dead weight on the rooftop for the different types of structures is shown. It is clear from the table that the dead weight is highest in the case of the ballast type structure because it involves the use of concrete blocks to hold the solar panels against the wind pressure. The dead weight for the ballast structure along with the panels is approximately 60 kg per square meter. We can also see here that in the case of the raised structure, the dead weight is more than the fixed structure. In the case of the fixed structure with the normal height, the dead weight can be approximately 20 kg per square meter. But in the case of the raised structure, it would be approximately 25 kg. For the tin shed type installation, the aluminium being very light in the weight, you can see that the long rail structure weight is only 8 kg per square meter. Whereas a smaller version of the structure which is not continuous, it is called short rail structure. The dead weight is only 5 kg per square meter. The average load bearing capacity of a slab is generally 150 kg per square meter. So it is clear that slabs are generally well capable of bearing the load of the solar power plants. With this, we have now covered the foundation aspects of the solar plants. Thank you so much for watching this. I see you in the next segment.